So section 2.1 is called Basic Assumptions, and it's about the properties of algebra. I've made this table here to summarize so I can go through the three main properties, which are the commutative, associative, and distributive properties. There are some other ones that we'll look at down below. So commutative property, and you may know these, or at least may have heard of some of them, but the commutative property for addition goes like A plus B equals B plus A. It just says that you can switch the order of the terms that you're adding, and they're equal. So A plus B is the exact same thing as B plus A. So order when you would add doesn't matter. In terms of numbers, that would be like 3 plus 5 equaling 5 plus 3. Now for multiplication, it looks like this. A times B is the same thing as B times A. So as long as you're multiplying, you can switch the order of the terms or of the pieces that you're multiplying. This doesn't work for subtraction. Now with numbers, it might look like 3 times 5 is the same thing as 5 times 3. Now associative property basically says that as long as you're adding or multiplying, you can group terms however you want in the way that's most convenient. So if I have A plus B grouped and C on the outside, which means I'd have to add the A and the B first, that's the same thing as if I wanted to move the parenthesis and now group the B plus C. And notice that the order hasn't changed. I've just changed the groups that I've chosen. So with numbers, that might be 3 plus 5 plus 6 is the same thing as 3 plus 5 plus 6. So here you'd have to have 8 first. 8 plus 6 is 14. In this case, you'd add the 6 and the 5 first, 11, then add the 3, but you get 14 either way. With multiplication, it goes like A, B. So if A, B are grouped, in one case, I could switch my grouping. I could move the parenthesis and now group B and C instead, and I haven't changed anything. So I think you get the idea. I don't think I need to do an example of that one. Now the distributive property, another really important one, goes like, if you have a piece on the outside of a parenthesis and you have terms on the inside, it doesn't have to be 2, it could be several, as long as they're separated by, it works with subtraction too, as long as they're separated by addition or subtraction, then you're going to distribute this A to all the pieces inside. So that equals A times B, then there's a plus side again, plus A times C. Now there is one for subtraction, although if you think of subtraction as really addition, you're just adding the opposite. This could work, this could cover subtraction too, but sometimes you see it written out like this. Same deal though, you're still distributing A to the B and A to the C. So A times B, keep the minus sign, A times C. So the distributive doesn't have an addition case and multiplication case. It's just distributive property. All right, now there's some other properties that you don't think of, or I guess they're not quite as important, but you still have to know them. There's the reflexive property. And This one is kind of funny. It just says a number or variable is equal to itself. So kind of obvious. You could substitute an A for an A because they're the same thing. Or 3 equals 3. This would be maybe the last step in a check. If you're checking a solution to an equation, you get to the end and 3 equals 3. This property allows you to say, yes, 3 equals 3. So you have to prove everything in algebra and geometry. Number 2 is the symmetric property. And this one I think of as like a mirror. So it goes, if A equals B, then B equals A. Don't mix this up with commutative. Even though the order is switching, I'm switching the left and the right side of the equal sign. There's an equal between them, and I'm switching the left side and the right side. So if you look up here at the commutative, I'm switching the order of terms, but I'm not switching the whole side of the equal sign. I'm just switching the order of the terms on one side. So there's a mirror, in other words, across that equal sign. So I could say x, let's see, this is an example, x plus 4 equals 10. If I wanted to rewrite that equation, I could put the 10 on the left and the x plus 4 on the right. And that's the reflexive property. All right, the third one is the transitive property. This one is seen, you'll probably learn it again in geometry. This is where I remember it more, is from geometry. And it says, if A equals B and B equals C, then A equals C. So if you link A to B, and then you link B to C, then A and C must be linked too. So here's an example with angles. If the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then the measure of angle A must equal the measure of angle C. So this might be used in a geometry proof. All right, time, I think I'm okay. I don't want to run my time too late. All right, let me give you some examples of the types of problems you'll see in this section. So I'm going to turn this over. Go here. So they're going to give you some calculations, and you'll probably, it's not really obvious or immediately obvious how these properties work into these calculations. But 803 plus 26 plus 47 plus 24. If I were to just add it in order from left to right, then there's a little bit more work than if I reorder these terms using the commutative property, because just looking at the numbers, 47, the 3 and the 47 add to 50. So if I want to switch the order of these two, because order of operation says you work from left to right. And then if I want to group these two also add to 50. And then I can even put parentheses, because associative says I can group them however I want. Then this is much easier to add than if I just started going left to right, because this adds to 850, this adds to 50, and that's really easy to add without even, you don't have to do any actual calculations on paper. Equals 900. So you don't have to rewrite like this, but see if you can find the easier way to do these calculations. But you are using, when you do that, you are using the properties, you just maybe don't think about the fact that you're using them. Example 2, something like 50 times 3 times 3 times 20. It's a little more work if I just started multiplying left to right than if I reorder, because 50 and 20 are easy to multiply in my head. So if I want to group those, and then the 3 and the 3 I can group separately, then I can do 50 times 20 is 1,000, and 3 times 3 is 9, so that's 9,000. That's an easier way to do it using properties. All right, example 3. Looks like 8 plus 9z plus 4. Well, when you add like terms, normally you just look at this and say, 8, that's 8 and 4 I can add together. That's 12 plus 9z. And that's how you should be doing it. But just so that you understand you're really using properties, what you're doing is switching these two. So you're going 8 plus, you're using commutative there, 4 plus 9z. And then you're adding these two. First you get 12 plus 9z. The commutative property is what allows you to do that. And when you have something that looks like, but you can just go straight from here to here when you do these. 3 times 4n. PEMDAS says you have to do the parenthesis first. Well, you can't, because that's a variable. There's no calculation to be done. But if I want to use the associative property and switch the grouping, I'm not changing the order, I'm just shifting the parenthesis over. Then I can multiply the two numbers together, and I get 3 times 4 is 12. 12n. So the associative is what allows you to do that. But when you do these, remember that you always multiply the number parts together and the variable parts get tacked on. And the number always goes in front. So let me show you another one of those here quickly. Example 5. Something like 6m times 4n. When you do that, without worrying about changing orders and stuff, you're just going to multiply the 6 and the 4 together, because those are the number components. And then you tack on the variables afterwards, like this. And the parentheses are gone, just like they were gone here. So this is how you write the answer to that. All right, that's it.